My name is Latina Taylor. I'm a NASA education specialist with NASA EPDC over at Texas State University. Take a look at the Robonaut. If you have never seen the Robonaut before, here he is. This is the Robonaut. This could give you a little bit about him. The Robonaut is actually a robot designed to look like a human. He has arms and hands with the intended ability to use the same tools that's used by astronauts on the International Space Station. And he's designed to complete a lot of simple tasks, tasks that actually test functions of dexterity, which, if you think about dexterity, this is skills in performing tasks, especially with the hands. For example, one test within the International Space Station's United States National Laboratory, the humanoid robot successfully grabbed onto a handrail and then got out a cleaning wipe and then started to clean the handrail. Now, this might not sound like much, but these and other initial tests that was completed by the Robonaut are the first steps towards a new era of robotics capabilities in space. So NASA, General Motors, and Oceaneering Space Systems, they're all working together to design robonauts that will stay aboard the International Space Station, assisting crew members with tasks and even interacting with them. Robonauts are especially helpful with activities performed outside of the spacecraft. And so, when these activities that are usually performed by astronauts, those jobs, which expose our astronauts to high levels of radiation. And so, if we had, these robots out there doing a lot of these jobs, that will, that would be a lot helpful. And so let's take a look at a really quick demonstration as I'm speaking about hand dexterity, again, skills performing tasks, especially with the hands. We're going to take a look at a snippet of the Robonaut demonstrating hand dexterity in action. There's no sound to this video. Now, this next snippet I'm going to show you, we want to see him do a little bit more with his hands and kind of think about how this will be very helpful, on the International Space Station.
The current Robonaut was developed as a result of a partnership between the NASA Johnson Space Center and General Motors. So General Motors sent down a team of engineers to work side by side with the NASA engineers, developing and assembling, designing, and building the current model of Robonaut R2. General Motors and NASA began working on the current Robonaut about 3 years ago. The relationship has been fantastic. The partnership's been fantastic, and as you see from the robot's a pretty amazing device.
Starting with R1, we went after both hands and arms. They give you a workspace and a dexterity that's very similar to a human. When we went to R2, we increased that. We increased the speed at which we could perform tasks, and we increased the level of dexterity so that we can even perform more tasks than the original R1 can.
From General Motors' perspective, we want to be able to automate tasks that are very repetitious, dull, or ergonomically challenging for our operators. And those requirements are very similar to some of the tasks that NASA would like to be able to automate to help an astronaut. So from that perspective, we're looking at using robots and automation to support our operators, to support our people doing the work doing the things that are not as value added for the operators.
Both organizations are looking for ways to add technology to both of our toolkits so that both space missions and assembly plants can be more efficient.
One of GM's core goals is to lead in advanced technology and quality in creating the world's best vehicles. The partnership with NASA and the development of R2 provide those innovative technologies that will help us achieve those goals in both our plants and our products.
The goal here is that there are many tasks that can be more efficiently offloaded to robots. For example, in space, when astronauts perform tasks, there's a lot of setup before the task is actually started and a lot of teardown after the task is done, particularly on space stations, setting up the tools, setting up a variety of equipment. If a robot can perform that task, it allows the crew person to be much more efficient doing the things that only a crew person can do. The partnership between NASA and GM has been a fantastic one, and it has resulted in benefits that we hadn't predicted when we first started together. Both sides are looking for as dexterous and as efficient a robotic system as possible. But what's also been amazing is the application overlap between the two groups. Many things that we have to do in space, that humans have to do, are in many ways similar to the complexity, the situation when you're building a car. Both are complex activities, and we have found interesting overlap that's been to the benefit of both of us.
For General Motors,
Okay, so we just got to take a look at, a little snippet of the Robonaut in action. And again, the Robonaut is doing all these activities and tests on the International Space Station. Just a little bit, we'll switch gears just a little bit, but not really. NASA's mission to send the first woman and the first person of color on the moon has a name, and that's Artemis. And hopefully you know about the Artemis missions. Artemis in Greek mythology is a twin sister of Apollo, and she was the goddess of the moon and the goddess of hunt. And this is so fitting, as the next generation of explorers will use innovative technologies to explore more of the lunar surface than ever before. And when our Artemis astronauts land on the moon, they will step foot where humans have never gone before, and that's the South Pole, the moon's South Pole. And we're going to talk about why they're going to the South Pole in particular, and all this, with the horizon goal of sending humans to Mars, which, Artemis begins our next, era of exploration. And we have our Space Launch System rocket and our Orion spacecraft, which are part of the lunar campaign, which is that first phase to get humans on the moon. And we just completed Artemis 1. Which is amazing to say. I love saying that. This was the first uncrewed test flight that went around the moon to test out all the systems. Let's take a look at this amazing shot. Liftoff, literally liftoff. This is NASA's Space Launch System carrying the Orion spacecraft right on top. And it's lifting off of Launch Pad Complex 39B at Kennedy's Space Center in Florida at approximately 1:47 a.m. Eastern Standard Time on November 16th, 2022. What a vision. The last time the space agency conducted a test flight of a moon rocket was the mighty Saturn V, and that was in 1967. Then 2 years later, the Saturn V rocket would launch the Apollo 11 missions, sending the first astronauts to the moon. That's another beautiful, beautiful shot. The primary goal of Artemis 1 was to thoroughly test the integrated systems before sending a crewed missions, to the moon. And basically by operating that spacecraft in deep space environment, testing Orion's heat shield, and then recovering the crew module after that reentry, descent, and splashdown. Let's take a look. I mean, first of all, what a moment, and let's congratulate NASA and the United States of America for such an amazing, amazing launch and recovery. Let's take a look, because this never gets old to me, at, um, at the blast off.
And there they go. The 4 core stage RS-25 engines gimbaling around, testing the ability to steer the rocket into space. They will operate at 109% performance, each RS-25 throwing down 500,000 pounds of thrust. All 4, 2 million pounds. All together with the boosters, 8.8 million pounds of thrust.
GLS go for upper stage to internal power.
Now the upper stage has gone to internal power. So power is removed from the rocket's upper stage, the ICPS, and it's been switched to battery power. The same milestone is coming up for the core stage at T-minus 1 minute and 30 seconds.
GLS go for core stage to internal power.
The rocket's core stage, which houses the 3 flight computers, is now on battery power. So there is no more hold time available because there's no more margin on the batteries. So if we have a hold, we'd have to recycle back to T-minus 10 minutes and recharge those batteries. The count continues. A note now, shortly after liftoff.
1 minute.
Shortly after liftoff, Mission Control Houston will take control of the rocket, and my colleague, Leah Cheshire, will take over commentary. T-minus 50 seconds and counting. Coming up at T-minus 33 seconds, the GLS will hand off control to the ALS. This is the autonomous launch sequencer. On board the rocket, it will take over command and control of the rocket. But the ALS will check, make sure there's no holds coming from the ground up until T-minus 2
GLS
seconds.
go for ALS.
And we are go for ALS. The Space Launch System is now counting down to liftoff of Orion on its maiden voyage to the moon. Launch team can no longer recycle the count. Sound suppressor water now flowing
15.
under the ML. And here we go.
10.
Hydrogen
GLS go
burn-off
for core
igniters
stage engine
initiated.
start.
7, 6, 5. Core stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
Engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour.
Yeah, and like I said, it just never gets old. I put the link to that entire video, and and at the end of this webinar, you will be able to access this entire slide deck presentation that it has embedded all of these resources for you to access as well. And like I said, it just never gets old, seeing that. And here's some amazing shots that have come back. This is a selfie pic. This is the Earth seen as the flight control team used the cameras on Orion's solar wings to do a thorough inspection of the spacecraft. Just a beautiful, beautiful shot of our home. And this is another amazing shot. This was taken on flight day 6 of the Artemis 1 mission. And it used Orion's optical navigation camera to basically snap this black and white photo of the moon. And Orion actually uses this optical navigation camera to capture imagery of the Earth. and the moon at different phases and at different distances, which it provides a lot of data to help certify its effectiveness under different lighting conditions. And it also helps to orient the spacecraft for future missions. Another amazing shot that was taken on the 6th day as well, where we get a really good glimpse of images of the craters that's on the moon. And talk about success. This is NASA's Orion capsule as it splashes down after a successful uncrewed Artemis 1 moon mission. And this happened on December 11th, 2022. And this was seen from aboard the USS Portland in the Pacific Ocean off the coast of Baja California in Mexico. And so the 26-day mission took the Orion spacecraft around the moon and back, completing a historic test flight, which, coincidentally coincided with the 50th anniversary of the landing of the Apollo 17 mission on the moon. We haven't been to the moon in 50 years, okay? And that was literally the last time NASA astronauts walked there. Here's another amazing shot. NASA's landing recovery team. This is that team bringing Orion capsule back into the deck of the USS Portland. That team, the NASA's landing recovery team, is actually comprised of about 95 people, which includes NASA's, Navy specialists, which you actually see piloting the inflatable boats there. NASA engineers and technicians from the Kennedy Space Center in Florida and Johnson Space Center in Houston, Air Force weather specialists, Lockheed Martin space operations personnel. So there's a big team of 95 folks that come together to bring Orion back, test him out to see how he did coming back home, literally a ball of fire. Also, there's a helicopter squad from a nearby Naval Air Station that provides that aerial spotting. And, so that was Artemis 1. So now we got Artemis 2 coming up. And so that will be a crewed flyby. This will be the first time humans will be at the moon in the 21st century. And we're going to do it aboard our SLS rocket, Space Launch System, the most powerful rocket on the planet. And our Orion space capsule will come back and do its thing. This will be a 10-day crewed test flight where we're going to be, and actually the NASA astronauts will set the record for the furthest distance of human travel from the Earth. And so while they're, in the Orion spacecraft, they're going to validate deep space communications and navigation systems. They're going to ensure that their life support systems are all intact, keeping them healthy and strong. And we're going to have those 4 astronauts in tow. One will be the first woman, one will be the first African-American or, person of color that will be, in that capsule. This will be the Artemis generation's Apollo 8 moment. When the astronauts aboard Orion will capture a full globe of the Earth from afar and the moon as their backdrop. What an amazing time, for our kids, for us to be a part of the Artemis generation. And then Artemis 3. Yeah, with all this confidence that we've gained with Artemis 1 and Artemis 2, Orion and its crew once again travel to the moon. This time, they're going to board a human landing system that will bring that first woman and that first person of color to the moon's surface. I wonder, what would those first words be? What would those astronauts say? Back in the day, our Apollo astronauts, they said, one small step for man, one giant leap for mankind. Hey, test your students out with this one. I ask kids this all the time. What do you think the Artemis astronauts will say? One third grader, he said to me, I think they'll say, hello, world. So you never know, pose that question to your students and find out what they think that our Artemis astronauts will say, when they land on the moon for the first time. They have a goal, they're going to be there for like 6.5 days. They're going to perform about 4 moonwalks, and they're going to have some real-time human responses and communicating back to home and collecting samples to bring back home. We're gonna go to the moon. We're gonna stay. We're gonna set up a base camp. Each Artemis mission to the surface will help us to test our landers, rovers, all to prepare for our mission to Mars. And each time we visit the surface of the moon, we will stay there longer. We will live on another celestial body, live and work, and then prepare us for Mars. Yeah. Everything we do and everything we learn about, during the Artemis missions will pave the way for human missions to Mars and beyond. And I want you to think about this. The students in your classrooms today, they are a part of NASA's Artemis generation. They are our next generation of innovators, explorers, scientists, technologists, engineers, mathematicians, that will help develop these new technologies to help pave the way and propel us to Mars and beyond. But we're not ready right now, to send humans to Mars, which is why we have what we call bots before boots. So in the meantime, NASA explore about Mars with robots, and so NASA has been exploring Mars for more than 50 years. Yeah, and we've had a continuous robotic presence on Mars since 1997. Which is amazing. NASA's long history of robotics successes at Mars has taught us more about the red planet than we ever did about the moon. And so, robots are literally paving the way for future missions to Mars. And what we are learning about the planet today is actually helping to inform future missions. And so who are our rovers here? When we talk about a rover is a motor vehicle that travels across the surface of the planet, Mars in particular, upon arrival. It has so many advantages. Rovers are able to examine more territory. They're able to place themselves in sunny positions, to weather winter months. There are actually goals with these robots. One, determine whether life ever arose on Mars. 2, characterize the climate on Mars. 3, characterize the geology on Mars. And 4, prepare for human exploration. Over the years, we have several robots. We have Sojourner, Spirit, Opportunity, Curiosity, and let's not forget our newest robot, Perseverance, who landed safely on Mars February 18th, 2021. And here's his Perseverance up close and personal. And, Perseverance, is very similar to Curiosity, where he will not only explore rocks and dirt and the air on Mars's surface, but he will collect and store rock and soil samples on the planet's surface that future missions will retrieve and return here home. Perseverance's mission is astrobiology, which includes searching for signs of ancient life on Mars. The atmosphere of Mars is made mostly of a gas called carbon dioxide. And many living things, including us humans, need oxygen to breathe. So if a human were to go to Mars, they would have to bring lots of oxygen. However, there isn't much room on a spacecraft to carry liquid oxygen. And so this rover will test a method for getting oxygen from the air and out of the Martian air, out of the Martian atmosphere. And so this will help NASA plan for the best designs to send human astronauts to Mars one day. a little bit more about Perseverance, he's studying a region on Mars called Jezreel Crater, which is believed to be an ancient lake crater that could have preserved ancient organic molecules from water that perhaps flowed there maybe billions of years ago. And so, so he's landed in that little circle area that you see here. And so computer scientists, this is where computer science comes in. Computer scientists working on Perseverance utilize the latest secure programming methods to ensure that the coding of the rover is protected. Perseverance did not need to be protected from just outside hackers, though, but also from bugs that could be introduced by future updates and from the harsh Martian environment. And so to do this, computer science actually use Linux operating systems to power the autonomous helicopter that we saw. That's Ingenuity. And Perseverance. And so these Linux systems are well known for their reliability and stability. And so the rover will be analyzing the environmental components of the planet, again, including searching for microorganisms using artificial intelligence. And none of this would be possible without the help of well-trained computer scientists. And so this amazing accomplishment actually shows us why it's important for computer science students to be well-rounded in both software and hardware requirements of a system. And this is just a snapshot of some of the instruments, the specialized instruments that are on board the Perseverance rover. Two in particular, when we talk about bringing those samples back, you look at the Pixel, which is an X-ray spectrometer, which will contain an imaging system with a high resolution that helps to actually determine fine scale element composition, which breaks down, what the Martian surface materials are. And it's capable of basically detecting an analysis of chemical elements, which is amazing. And then you have the Sherlock, which is also connected there. And this spectrometer will provide that fine scale imaging and use ultraviolet lasers to basically determine minerals and detect organic compounds. And so again, he's looking for signs of past life. Let's take a look at how do rovers drive on Mars. I love this video because you can show this to kids. It's a 1-minute video and it just breaks it down so eloquently for kids. So let's take a look at that real quick.
How do rovers drive on Mars? First of all, there's no joystick for driving a Mars rover. Before a rover hits the road, engineers send computer commands overnight, telling it where to go the next day. Depending on how tricky the terrain is, rover drivers have two options. They can send a string of specific commands like drive forward 5 meters, then turn right 90 degrees. The rover turns its wheels enough times to add up to 5 meters, and then turns in place. Or if it looks safe, they can let the rover think on its own. They write commands like, see that rock over there? Find your way there safely. Then, using two cameras like human eyes, the rover gets a 3D view of hazards such as large rocks and steep slopes. After mapping the danger zones, it plots the safest route to avoid them. Either way, did the rover complete its drive as planned? Engineers double-check when the rover sends back a postcard of its new spot on Mars.
Let's meet Viper. Viper, NASA loves acronyms. So let's take a look at Viper. Viper is NASA's, the acronym is Volatile Investigating Polar Exploration Rover. And this is an illustration of NASA's Viper rover. Basically, it's a mobile, I'm going to say basically, but it's not really basic. It's a mobile robot that will basically roam around the moon's south pole looking for water ice. Yeah, so I don't know if you know, but NASA detected water ice on the moon's south pole. From SOFIA. SOFIA is a telescope that lives inside of a Boeing 747 airplane, and it detected the water ice on the moon's south pole. And so the Viper mission will give us surface level detail as to where the water is and how much is available for us to use. This will bring us a significant step closer to NASA's goal of a sustainable long-term presence on the moon, making it possible, for us to eventually explore Mars and beyond. And so we're sending this a robot Viper to the South Pole to get that view of the location, and the concentration of the water ice, and possibly actually sample the water ice, where our first woman astronaut and our first person of color will land. He's about the size of a small golf cart. And so he's going to roam for several miles, using about 4 of his science instruments. One includes a 1-meter drill that will basically sample various soil environments. And he's planned for delivery, sometime in 2023. And so he has a 100-day mission that we will be collecting lots and lots of data to help inform us of this first global water resource that's going to help us give us a map of where the water is on the moon. So this is a huge opportunity of learning and gathering. Let's take a look at this quick video where we can learn a little bit more about Viper and what he will be doing on the moon. Yeah, it is a nice video. Something that's definitely a video that you can share with students, right? For more information regarding NASA's innovative technologies, visit Explore Space Tech. This is an amazing site. This is your one-stop shop for everything NASA tech and computer science. Has videos, pictures, interesting facts, live data. It has topics like space travel, living in space, robotics, scientific instruments, high-tech computing, so much more. So take a look at that site. It's well worth it. And I just want to put in, this is a map of the NASA centers that's located all across our country. Every NASA center contributes to Artemis, right? But I also want to let you know that all 50 states, this is such great news, exciting news, contributes or has contributed to the Artemis mission. So this is not just NASA doing this. This is the United States of America that is going back to the moon, that has gone back to the moon. And so, this is a proud moment, for our country. Hawaii, very good question. I'll get back to you on that. I'll find out if Hawaii is a part of that. I don't know, just a little bit about me. I don't know if you guys, I get a chance to introduce myself a little bit. My name is Latina Taylor, NASA education specialist with NASA EPDC, former Chicago public school teacher, taught with CPS for over 24 years. My various capacities. My last role with CPS was a STEM specialist, so I taught STEM classes. And one thing I wanted to share with you guys is, I talk about robotics because I was totally into robotics when I was teaching. These are two of my students' award-winning underwater robots. I say award-winning because literally both of those robots won first place in the Midwest region of the United States for underwater robotics competitions. I got a chance to take my middle school students to international competitions where they competed with literally kids and high school kids and college kids from literally all over the world. And so, I have a fascination with robots and programming, which is why I, was attracted to, programming activities with NASA and creating this webinar for you guys. Our agenda, we're going to take a look at the next generation science standards a bit, and then go into NASA's best engineering design process activity guide. This educator guide is amazing. It gives you opportunities to bring engineering into the classroom. And then we're going to look at one activity within that educator guide called Prepare for a Mission, which includes opportunities for kids to connect with the Robonaut, connect with the Artemis missions, connect with water, on the moon, as they are literally, their challenge is for their robot to retrieve lunar ice. And so that's how you bring, all of these NASA missions into the real world connection with kids. So, and we'll get a chance to talk about that a little bit more. At the end of the webinar, you will have access to download an entire PDF version of the slide deck. So you'll get all these slides, and then all these documents that you see here, these educator guides and rubrics, fact sheets about Robonauts, and so much more. You can download all those things right here within Adobe Connect interface. And I'll also provide you with a link, a Google Drive link that you'll have quick access to download everything as well. Just give you a little bit. I'll give you a little bit of history here about, NASA with computer science in particular, where we're going to go take a look at NASA's West Area Computers. This is where Black women performed complex mathematics for the United States Space Agency. The war opened up doors for African Americans in 1941 under pressure from labor and civil rights leaders like A. Philip Randolph. And so President Franklin Roosevelt, at the time, he signed an executive order, 8802, which created Fair Employment Practices Committee. This committee, basically, it was about prohibiting race-based discrimination in the country's defense industry. So shortly thereafter, help wanted signs began to appear in African-American newspapers all across the country. And they were looking for Blacks to actually fill positions in the federal agencies and defense contractors. And so Langley advertised seeking machine shop workers, laborers, janitors, and African-American women with math degrees. And so in 1967, Christine Darden was added to the pool of, and I'm air quoting this, human computers who wrote these complex programs and tediously crunched numbers for engineers over at NASA's Langley Research Center. But Darden, she wanted to do more than just process data. She wanted to create the data. And so after wading through daily calculations for 8 years, Darden approached her supervisor and asked, why do men with the same educational background as her, basically a master's in science and applied mathematics, they were hired as engineers. And so he was impressed by her skills. Her supervisor transferred her to the engineering section, and where she was one of the few female aerospace engineers at NASA Langley during that time. And her first assignment was to write a computer program for the sonic boom. So this is an amazing lady, Dr. Christine Darden. And, this story actually comes to light with the release of the 2016 book, Hidden Figures, and the film that came after it with the same name. And so it's the story of Black women who worked at NASA and in the South specifically. And at that time, computers were not machines, but people, people who performed complex mathematical computations with slide rules and graph paper. And so the engineers admit themselves that the girl computers do more work and more rapidly than they could. And so this is a picture of the author. Her name is Margot Lee Shetterly, and she is actually, her father was an atmospheric scientist at NASA, and her mother was an English professor at Hampton University. And so she did the research and wrote that amazing book, which became a beautiful movie for all of us to, share with this new generation of future engineers, scientists, mathematicians, and technologists. This resource here, Computer Science Educational Resources, for more resources on computer science. And this is an amazing site. Check it out. One thing you want to think about, the most important aspect of computer science is problem solving. And that's just basically an essential skill for life. And so students study the design, development, and analysis of software and hardware, and use this to solve problems. So businesses need this, scientists need this, social contexts need this. So computer science is just so important. It's an important element in strengthening our existing educational models and to preparing students for the future. We recently celebrated Computer Science Week. I wanted to put this here because, hey, this site here has some amazing resource that you can use, amazing resources. It also includes a video from the International Space Station, talking to kids about the importance of computer science and coding. Dr. Jessica Watkins speaks on there, so take a look at that video, a really great video. Looking at the standards here, this is our next generation science standards. We have the 3 dimensions of that framework, which goes into the practices, the core ideas, the cross-cutting concepts, those practices. This tells us what the scientists and the engineers do. What do they do? What do the scientists do to investigate the natural world? What do the engineers do to design and build systems? And then you have those core ideas. That's that content knowledge, and they're broken into 4 domains. You have your physical science, your life science, your earth and space science, and then and engineering design. Engineering design is a part of the standards. It's what students should know and be able to do. And we're going to talk more about that piece too. And then you have the cross-cutting concepts. This describes how students think and link to those core ideas. So if you have a concept like cause and effect, well, this is made explicit to students so that they can develop a more coherent and scientifically based view of the world around them. And so you want to know more about the NGSS? Take a look at that link here, nextgenscience.org. And I said, why engineering, right? Why? The NGSS actually provides a foundation, a great foundation for engineering design that encourages students to design a wide range of solutions to problems that arise from scientific phenomena. Okay, and so this is a screenshot of Appendix I. You'll be able to download this. It's a really, really quick, great read. And I want to hone in on that italicized paragraph that you see here in the middle of the page. I'm going to hone in on that, where it says, and it actually gives us that insight as to why engineering. And so it says, we anticipate that the insights gained and interest provoked from studying and engaging in practicing science and engineering. So science, engineering, and K-12 schooling should help students see how science and engineering are instrumental in addressing major challenges that confront society today. So that real world connection, like generating energy, preventing and treating diseases, maintaining supplies for clean water and food, and solving problems of global environmental change. So that engineering helps with the science of the real world, right? And then we have, the engineering design process. This is NASA's best. I really, really like this flow chart, because that circle just tells everything, right? So if we want to encourage our young students to think more like scientists and engineers, we let them know that engineers use a process to guide them, which includes a series of steps as they're solving these problems. And this is the engineering design process. First, there's a problem. They need to find out what is the problem. And then they're imagining solutions by brainstorming and researching. And so and they're doing this as a team, because engineers work in teams. And then they come up with a plan. That plan could be a sketch, a blueprint, a diagram. It could even be a mathematical equation. So they come up with the plan, right? And then they create it. They develop a working model. They put that plan into place. They come up with a model or prototype, and then they test it out. They collect data to see what's working, what's not working, and then they're making improvements on it. And so as they're making improvements, they might have to go back to that plan, do some more creation, do some more testing, to finally they're ready to share and communicate their results with everyone. Now we're going to get into the NASA STEM activity that comes from NASA's Best, an educator's guide to the engineering design process. This is a screenshot of the educator guide. And I want you to take note that you see this educator guide broken down in grade levels. You have a K to 2 version, a 3 to 5 version, and a 6 through 8 version. And this guide helps to nurture those 4 C's of STEM, that are crucial 21st century skills of communication, collaboration, creativity. Okay, that goes into that, that higher order thinking, collaboration, and innovation. Okay, and that's a link to where you can download these PDF versions as well. But I've also downloaded those, and it's a part of your handouts that you'll be able to access today. And so this educator guide is organized really well. They have teacher pages, which includes the goals and objectives, gives you the process skills that the kids will be, obtaining, the required materials, the design challenge itself. The page offers strategies, which I love, strategies to help motivate students and set that stage for learning. And you also have the student pages. So the student pages, you have the students have keywords. It gives them that NASA background information, which ties into the missions, real world NASA missions. Suggested steps that the students can take as they go through the engineering design process, data tables to complete, questions to help guide their thinking, and it also has extension activities that they can take home or involve family with. What's amazing about this is that students receive the challenge requirements, the constraints and the materials. But there's no specific instructions or on how to solve the problems. Students work together in teams and come up with the best solution. And this process, it could be a little challenging, teachers and students at first, but once students start thinking in this way, it becomes just a natural way of how students are learning, how the business of the classroom is being conducted. And this is just a little bit of how the educator guide looks, how it's fanned out here. One thing I want you to take note of the pictures and the connections to the NASA missions. And there's our Robonaut. So bringing the Robonaut in, because as they will be working, oh yeah, this is a fantastic resource. As they will be working, again, they are thinking about the real world missions that are taking place. For this particular activity, we're going to look at, you can see this particular educator guide has quite a few activities. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 activities in this particular educator guide. We're going to take a look at the third activity, which is called Prepare for a Mission. Now, I want you also to take note that these actually build on each other. So that's an idea too. You might want to do it, in order, or you can do them out of order, but they build on each other. So we're going to look at Prepare for a Mission. And for this particular activity or design challenge, the students will basically execute a mini simulation of a robotic mission with the goal to command a human robot through a set course to retrieve a piece of lunar ice. Okay. And here are our objectives. They will demonstrate an understanding of the engineering design process, that process that we just walked us through, while utilizing each stage to successfully complete a team challenge. So they're going through each stage and completing that challenge with success. And here are some of the process skills that they will be obtaining. Mapping, communication, measuring, graphing, logical thinking. And here's that set the stage. You can, again, strategies to help, motivate the kids, get them going. Spend a few minutes asking students, if they know what engineers do. What is an engineer? Have that conversation with students. And this video is a really great video. What is engineering? And you can actually explain to students that many of NASA's missions are conducted by robots. It maybe ask students to draw their ideas of what a robot looks like, and then compare, their differences. Doing that, what do you know about robots question is an amazing way to get it going, right? To activate that prior knowledge. You can write the word robot on the board and ask them, to describe, a robot, and this could be for all ages, and have them to record their ideas in their, science or technology notebooks. Draw a picture of a robot, or leave it open-ended, imagine what a robot, could do. What could a robot do for you? Just getting them to, again, activate that prior knowledge. And then that question there, how do robots assist humans in space? How do they think they assist them? So again, activating that prior, and why do we do this? Why do we activate prior knowledge? Well, students bring what we call funds of knowledge to the classroom, which includes their background knowledge, their experiences, their skill sets that they have just to navigate through their day. And oftentimes the hook that we have is that background knowledge. When we acknowledge background knowledge as assets, and tap into it, we actually creating an optimal environment for learning. But for sometimes for students of color and other underserved diverse student populations, those assets are often overlooked or underutilized. And then what happens is that we actually miss out on a chance to support that rigorous learning. And so, this is a lot, this comes from a lot of the work from Zaretta Hammond, who is a leader in culture responsive teaching. And so, then, how do you hook kids, right? With that real world connection, right? And what better way to do it is to utilize NASA's unique assets, and engage STEM with the agency's missions, and in this case, the Artemis mission. And so, as educators, we have a responsibility to introduce 21st century STEM careers to our students early on, so that their perceptions of scientists, technologists, engineers, mathematicians mirror what these STEM professionals look like today. Engage them or expose them to new job titles, and in this case, a robotics engineer. Engage them in the real work that this job title might experience. And so what it does is it increases their awareness and exposing them to, various career, pathways, and a slide like this actually came from a student, because I would say to kids, okay, today you'll be aerospace engineers, and I'll get a hand raised, and the kids will be like, well, how much money do they make? And I'll be like, oh, okay, why don't you look it up and let us know? So this slide actually came from students asking that crucial, important question, how much money to make, and what kind of schooling do I have to have? So, giving them that, right up front, here it is, and this is what you need in order to, become that, and then meeting a actual robotic engineer. NASA's Career Corner, this is an amazing link. So when you go there, you'll actually see other career options as well. But they get a chance here to meet an actual robotics engineer, someone that works, for NASA. And then another opportunities to meet a computer scientist, and the link here gives us a little bit about John Bresnia, who his official job title is a computer scientist. But I love his quote here. He says, it is never too late to discover your life's passions. And once you have made this discovery, it is never too soon to start pursuing it. So, what a quote, to give to students, for, that inspiration that they need, right? NASA Eclipse. If you don't know about NASA Eclipse, you need to know about NASA Eclipse. These are short, relevant educational video segments. These videos are amazing. They are created to inspire and engage students, to help them see those real world connections. And so I just put a screenshot here. This is Dr. Lene Quick, who is a planetary geologist, who shares her love for creative writing, and her excitement that she sees when she sees new images from space exploration. So if you don't know about NASA Eclipse, check out NASA Eclipse. And so as you are engaging kids, these are some sample group roles that you can put them in. Group roles help kind of divide the work more equally. It actually reduces the chance that one member, is kind of taking over the challenge. And so these are just some sample group roles, and here's their mission, right? Their mission they've been chosen to operate a robotic discovery mission on the surface of the moon. Now that they've been learning all about the Artemis missions and they've been introduced to the Robonaut robot, now we're giving them a mission, right? You'll be given a specific starting location, and your robot must move through a lunar landscape to the location of lunar ice. Especially now that they know there's water ice that's on the moon. And Viper, is making a map of this, right? And so you're making those connections with them. And so to successfully complete the mission, their robot must pick up a piece of the lunar ice. And here they're going through that engineer design process. They're going to create a route. And so this is where you want to share that mission, and check out the student pages here that kind of help guide them through the actual challenge. I know I'm a little bit over. We only have a couple of more slides, and then we're going to get to the ending. Thank you so much for staying. Criteria and constraints are so important when you're talking about an engineering design challenge. Criteria are those things that the design needs. It needs in order for it to be successful, its requirements. And those constraints are those limitations. This could be the materials, the cost of the materials, the amount of time that they have to come up with a solution. And so here, they, number one, must designate their robot. So one student in the team must be the robot, be the person who will walk the course blindfolded, following the instructions that the team gives to this person. And the team should give their robot a name. Then they should make a map of their robot's route. And then learn to communicate with their robot. They have to come up with commands, for their robot, and then program the robot. Using their commands that they've come up with, that they practice. Now, how are they going to program that robot to follow their commands? And then there is some pre-activity setup. And so you want to set up a small obstacle course, with a few chairs, waste paper baskets, or a table. The course doesn't have to be too complicated, but you want to set it up so the students have at least, one right turn or one left turn. You also want to give them enough obstacles that there's a path to take that finish line, to get to the finish line. And this activity takes about 60 to 90 minutes to complete. And so also, the student acting as a robot will need to be blindfolded. So you want to make sure that you want to take the time with your students to discuss, safety, and what that looks like. And here are the materials: low cost, low budget. I always say that because it's so true. Rulers, meter sticks, stopwatches, blindfolds, their prize, or whatever their lunar ice is going to be. And then those crucial student pages that will help them as they go through this process. And then actually experiment. Okay, the time to experiment it, the teams must navigate through their obstacle course, position their robots, and the robots actually perform the actual commands. And then each team must record how much time it takes for them to successfully complete the task. And then as they are experimenting, it's time to program it. Program their robot. Each team member, the team, the students designate to deliver the commands are the ones that take one command at a time. One student walks to the robot, delivers one command, then returns to the team. The robot performs the actual command. And then here's your data table. You can use this data table to record the time that it takes to complete the mission. And then the teams can then compare, how much time that it took to finish their obstacle course. And then you always want to give opportunities for kids to communicate, right? To reflect on their learning and communicate the science and the concepts and ideas that they have discovered. So these questions are amazing. Did each team pick the same route, or were there several routes to get to the lunar ice? Which route worked the best? And so these final slides here, and also you can also think about, when I'm going back to this slide, sharing this with families, involving families, with extension ideas, which are also embedded within the educator guide as well. And these are just some additional computer science resources that you will find embedded into the slide deck as well, along with robotic lesson plans that you can use to coincide with this particular educator guide and those challenges. I'm going to go ahead and move us to the closeout. And I appreciate you so much for staying a little bit extra. Thank you so much. There are several handouts here where you can download everything. And so you have about 9 documents here that you can download. I'm also going to put in this link here into the chat. This is your Google Drive where you can access everything quickly right there for you. And happy holidays to everyone. Merry Christmas, Happy Hanukkah, Happy New Year, Happy Kwanzaa, Happy Holidays. And be safe out there. I know in Chicago we have a blizzard coming. I'm laughing because I'm just going to be in a house. Blizzard is coming. So be safe, everyone. Thank you.